In this video, we're going to conclude our discussion of automatic memory management with the third and last technique we're going to talk about for garbage collection called reference counting. So the basic idea behind reference counting is that rather than waiting for memory to be completely exhausted, we're going to try to collect an object as soon as there are no more pointers to it. So as soon as we discard the last pointer to an object and it becomes unreachable, we will try to collect it at that point in time. And how can we do this? Well, as the name suggests, we're going to count the number of references to each object. So in each object, we're going to store the number of pointers to that object. So if I have an object in memory, and it has, say, 3 pointers to it from other objects, then somewhere in this object is going to be a dedicated field that contains the number 3. And if this number ever drops to 0, if we discard these pointers and this number becomes a 0, then we know that nobody's pointing to this object and it can be free. And what this means is that every assignment has to manipulate the reference count in order to maintain an accurate count of the number of pointers pointing to an object. So allocating a new object returns an object with a reference count of 1. So when an object is created by new, it will already have a reference count of 1. The pointer that is returned is the only reference to the object. And so we're going to write the reference count of an object x as rc of x. And now when we have an assignment, x gets assigned y, we're going to have to update the reference counts of both the object that x points to and the object that y points to before the assignment. So what happens here? So if y points to p, so let's draw our objects here. So y is a local variable, and it points to some object p in memory, and x is also a local variable, and it points to some object o. Okay, so now x is getting the value of y, and so that's going to move this pointer from where it pointed before to point to the same thing as y. So what's going to happen? Well, p's reference count is going to go up by 1, and o's reference count is going to go down by 1. And since we decremented o's reference count, since we dropped this pointer to the object o, we need to do a check to see if the reference count has become 0. And if the reference count has dropped to 0, then we can free the memory for o. And then, in addition to updating the reference counts and checking whether the reference count of o became 0, we actually need to do the assignment itself. All right, so every assignment, I want to stress that, every single assignment in the program gets now translated into these 4 operations that need to be done to maintain the reference counts. There are trade-offs in reference counting. It has advantages and disadvantages. One of the big advantages is that it collects garbage incrementally without large pauses in the execution. So for applications where large pauses would be problematic, say real-time applications or interactive applications, reference counting can really help because it minimizes the length of the longest possible pause. Okay, so your program will never go to sleep and just appear to stop running for some period of time because it's off collecting garbage. It always collects the garbage in small incremental amounts, and so you never see a long pause. Reference counting, or at least a basic implementation of reference counting, is also quite easy to implement. It's very straightforward to go through and modify the code to add reference counts, and you can easily imagine a code generator that would simply generate different code for the assignment operation than it normally did if you were adding reference counting to an implementation. So really the changes that are needed for a simple implementation of reference counting to a compiler are not that pervasive. Now, there are some disadvantages to reference counting. One is that manipulating the reference counts at each assignment is really quite slow. So if you remember what happens, we have a couple of updates to reference counts. So we have to update, the reference count of 2 objects to do this is the code to do an assignment, and then we have an if statement, and then we actually do the assignment itself. So there's 2 reference count updates, a test to see if a reference count became 0, and then we actually do the assignment. So the overhead here is substantial. You're taking every single assignment in the program and blowing up its cost by at least 4 or 5 times, and that will have a very noticeable impact on the performance of many programs. Now, it is possible to optimize reference counting. So for example, if we had 2 updates to the same object, say within a basic block or even within a control flow graph, A compiler, a smart optimizing compiler, could frequently combine those reference count operations together. So instead of updating the reference count of the object 2 times, it could just update it 1 time. And similarly, if there were even more reference count updates to the same object, potentially all of those could be coalesced within some region of the program. The problem with that is that it becomes very tricky to get that right. So a simple implementation of reference counting is quite slow, but easy to get right. A very sophisticated implementation of reference counting or highly optimized implementation of reference counting is somewhat faster, still has a noticeable performance impact if you're reference counting all objects, but it is substantially faster. However, it's quite tricky to get it correct. The other problem with reference counting is that it cannot directly collect circular structures. So to see this, let's draw a little heap with a circular structure. And so let's say we have a local variable x, and it points to some object in the heap. And that object has a pointer to another object. All right, and that object, that second object, then has a pointer back to the first object. Okay, so here x is pointing to, say, a circularly linked list of length 2. All right, and if we add in the reference counts here, what would those look like? Well, this object down here, the second object here has only 1 reference to it, so its reference count would be 1. And this first object has 2 pointers to it, 1 from x and 1 from the other object, and so its reference count is 2. Okay, so here is our little heap, and we can see that there's no garbage here because all the objects are reachable from a local variable or a variable of the program. Now, if we were to assign a new value to x, let's say that we had the assignment x gets null. All right, so this pointer goes away. Well, what's going to happen? Well, when we do that assignment, we're going to change the reference count here of this object. It's now going to be 1. And if we look at this heap, we now see that these objects, these 2 objects are unreachable. Okay, so these are unreachable. But notice that their reference counts are not 0. So we can't collect them. The garbage collector or the reference counting implementation will check the reference counts and see, oh, these are 1, and so we can't delete them. And what it can't see is that the only references to these objects are from other unreachable objects. So the bottom line is that reference counting can't collect circular structures, and there's only really 2 ways to deal with that. One is that the programmer remembers whenever a circular structure is going to become unreachable to somehow break the circularity. So for example, if before we clobbered the pointer to x here, we remembered to go in and say set this pointer here to null. If we nulled out 1 of the pointers in this cycle so that there was no longer a cycle, then the reference counting would work correctly, because then the reference count of this object would go to 0 when this pointer was dropped from x, and that would cause the reference count of this object to also go to 0 after this object was deleted. Okay. The other possibility is to back reference counting by some other garbage collection technique that can collect cycles. And so in some reference counted systems, for example, most of the garbage collection is done by reference counting, but every now and again, once in a very great while, you might run a mark and sweep collector to go through and clean out any circular but unreachable data structures.